Okay, so in this section we're going to talk about the integrals that we already know, and then a few new ones to add to the list, and then how to use those on practice problems. So this should be stuff that we can deduct from the derivatives that we've already memorized, as well as this page. This page that I can't turn to, there we go. This is also all of our derivatives that we've already memorized backwards, set up as an antiderivative. So what we should be able to do is take the derivative of this side, and we're going to get this this side right here. And these are not new. This is something you've memorized. We're just writing it backwards now because we're talking about an antiderivative. So there's a few more that I want to add to the list, and it's going to be the trig that's not as common as these. So it's not something you've already memorized. The weird thing is it's going to look more simplistic on this side, but it's kind of going to be a mess on the other side. So, for instance, the integral of tangent, you would hope, is just something easy, or maybe you're going to think it goes with secant squared, but you've got to be careful because we're doing an antiderivative, and it actually ends up turning into this. Now, the proof of that is to turn tangent into sine over cosine, and then you can let u equal your denominator, and you can prove this, and you can get it, and it's not a huge deal. But it's better to memorize these just for speed, okay? And deriving these two is actually quite horrible. So keep these in mind whenever you see the integral of these, that we do have these that we can use, and just memorize. Okay, so now let's do some practice, okay? To practice these, we've got 10 problems. Some are integrals, some are derivatives, just to make sure you still know how to take a derivative. But let's go ahead and just start right off the bat with number 1, which is 5 cosecant of x, okay? So whenever you're handling something like this, you've got a coefficient, so remember it's okay to just bring that coefficient out front and then recopy the integrand, cosecant x dx, okay? And this right here is one of the ones I just showed you on the list of new ones we want to memorize. So if you know that, all you're going to have to do is recopy your 5 and then do the integral of cosecant, which is just the negative natural log of cosecant plus cotangent. That's a plus. And then plus c at the end. So this is all you're going to have to do for number 1. All right. For the second one, it's kind of actually very similar. This 2 on the top, if it freaks you out, just move it to the front of the integrand. And so you're really just looking at this. And hopefully you recognize that as one of our derivatives that we know, but it's backwards. So we know that the derivative of natural log is this, which means that the antiderivative of 1 over x must be natural log plus c, okay? And we talked about the absolute value signs in class today, so you want to make sure you have those, okay? All right, moving on to number 3. Okay, with number 3, this right here is weird, because if it was just e to the x, then I would just take the integral as e to the x. But there's a function stuck inside another function, and if you look carefully, the derivative of this function is sitting out front. That should scream u substitution, okay? So I'm going to do that down here. So I'm going to let u equal the 4x, okay? And then the derivative of that would be 4 dx. And this matches what I see here exactly. And so what that means is it's going to turn this whole integral into the integral of e to the u du. And then when I take the integral of that, it's just e to the u plus c, and my u was 4x. And if you want to check yourself, remember you should be able to take the derivative of this, and it's going to equal what you started with, right? So if you chain rule that, it definitely works out, okay? All right, number 4. So for number 4, you might be tempted to do a u substitution, but what's going to happen is, let's say you choose this for u. Well, the derivative of that is just 1, and then you're going to be stuck with this, wondering what to do. This, even though it's in parentheses, there's no exponent here, and there's no square root. So it's really not stuck inside another function, which tells me there's an algebraic approach to this. And if you just rewrite this as x to the 1/2 times x plus 1, then maybe that'll help spur the decision to distribute, okay? So x to the 1/2 times x to the first is x to the 3/2, okay? Plus x to the 1/2 times 1. And now this is your new problem. And this is pretty easy to integrate right here. So we're just going to have add 1 to that. So it'd be x to the 5/2. And instead of over 5/2, I'm going to write it as a 2/5 out front. Okay? Plus add 1 to that. It's x to the 3/2. And instead of putting it over 3/2, I'm going to put a 2/3. And then plus c. So no u substitution was even needed at all on that problem. Okay, the last problem definitely need a u substitution. This whole thing right here is a function stuck inside another function. So you can't manipulate it with algebra. So that's going to let me know that that's my u. When I take the derivative of both sides, this is what I'm up against. And right here, instead of a 3x squared dx, it's a 4x squared dx. So the way we want to think about this is that you could have moved this 4 out to the front in the very beginning, okay? And so this is what we would be looking at. We could go ahead and plug the u in here, and we'd be dealing with an x squared dx that we need to replace. So if you look here, if you want to get this x squared dx by itself, so that you can replace this, you just move that 3 to the other side. So this is not new. This is what we did on Friday and in the last video. 1/3 du, what am I at? Okay, so this looks like it works. So now I can replace both of these with a 1/3 du. And I like to move things around so it looks pretty. So that 1/3 is coming out front. The square root of u is the function, and the du should be in the back for notation. We're taking the integral with respect to u. And so whenever you mess with this now, it's just u to the 1/2. So the answer to this will be 4/3, and then u to the 1/2 plus 1 is 3/2 over 3/2, or times 2/3, okay, plus c. And then when we clean this up and substitute our u back in, it's going to be 8/9 x to the 3rd plus 3, all to the 3/2 plus c. Yay! So hopefully that's not too terrible. If you're done and you got the derivatives, then just do, hit stop. But if you want to see me work the derivatives real quick, I'll do that as well. Okay? So now it's derivative time. Okay, right here I see two things multiplied together, so I need a product rule. So I'm going to call this one F, this one G. And so the first times the derivative of the second. Well, the derivative of e to the x is still e to the x, plus the second times the derivative of the first. And the derivative of tangent, hopefully we have memorized by now, is the secant squared of x. So that's it. If you want to factor out an e to the x, you can. Not required. You can leave it like this. I'm okay with that. Okay, the next one. The next one's just kind of some power rule stuff, okay? So on this one, we're just going to do the derivative of this term, which bring the 3 to the front. So it's a 12x squared minus 1. And then the derivative of cosine is actually a minus sign. And that's it. That's all she wrote. And if you're wondering why I'm making you do this, guys, it's because when you get caught up in antiderivatives, sometimes you forget how to take derivatives, and this needs to be your bread and butter. This needs to be like, I can do this in my sleep, and then this part I have to think about a little bit, and I kind of hope that's how it is, but you may have forgotten, so we're going to make sure we're always practicing these, especially one like this. This is a chain rule. The 3 is just a 3, so hopefully it's not scaring you, but you've got a function stuck inside another function, so we're going to have to chain rule it. So I'm going to do the derivative of the outside function, which means I'm recopying the 3, and the derivative of e to the something is e to the something, okay? But then we have to chain rule it, so we have to say times the derivative of that something. So the derivative of that exponent is a 4. And then we pull all that together and have 12e to the 4x plus 5. Okay, and that's what your derivative should look like. Okay, the next one is also a chain rule, and it's a little trickier because it's a function inside a function inside a function. So I'm going to rewrite it so that you can see it, because really this entire cosine, everything here is being squared. So the outside function of this chain is the exponent. So step 1 is power rule, so bring the 2 to the front, recopy your function, and then now it's to the first power, which I don't really need to write, but it's to the first power, times the derivative of the inside. Well, the inside is 2 parts, so it's almost like you're going to do the middle layer first, which the derivative of cosine is a negative sign. So I'm going to stick the negative in the front, and I'm going to have a sign here, and it's the sine of 5x. I'm just recopying the function I see, and then times the derivative of the very inside piece, which is a 5. So when I pull all this together and clean it up, I'm going to write it as negative 10 cosine of 5x sine of 5x. And that would be a good way to leave your final answer. Okay, and last but not least, it's a quotient. If you want to quotient rule, you go right on ahead. I'm actually not going to quotient rule this because I'm going to split it up kind of like we were doing on some integrals the other day. If it's easier to split up and do a power rule, then split it up and do a power rule. So this is going to reduce to 2 over x minus, this is, you could think of it as 4x to the negative second. And now I'm just going to take the derivative of each of these, okay? The derivative of this one, this is really like x to the negative 1. So you could think of it as 2x to the negative 1. I'm going to ignore that now, okay? And we're just going to power rule it. So it's negative 2x to the negative second, okay? Minus, we're going to power rule that. So bring the negative 2 out times the 4. I think that'll make a plus 8. And then x to the subtract 1 from that, and it's a negative 3. And now clean up your answer. I don't want negative exponents ever, okay? So we should be able to do that, and now all is right with the world. Okay, so that's it. Hopefully that went well for you. If not, come in and see me, please.